Hello everyone. Today we'll see a topic on the rectilinear figures, which is also called as the quadrilaterals. So rectilinear figures is basically the chapter name we use in ICSE for class 9, and the quadrilaterals is the name that we use in CBSE. So for both the boards, it's a very important topic, very basic chapter, and based on these concepts, we are going to further follow and relate the same things in the upcoming geometrical chapters, right? So that's why we are going to understand the concept totally in depth. Okay, so those who are new to this channel, do subscribe to the channel so that you don't miss any important video related to any topic. So you're watching GANITMATICS. I'm Michael Datta. It's a one over solve. So let's begin with the topic. A quadrilateral is basically any closed figure which is made up of four sides. This we all are already aware of. Now, what are the different type of quadrilaterals that we are going to have, and what are the further subtypes, and what are the properties? Everything today we are going to see in this particular video. Okay, so first we are going to start with the types of the quadrilaterals. So basically, we have three basic type of quadrilaterals. The first that we have is the trapezium. That is the first type that we all need to know. The second one is the parallelogram. And the third one is called the kite. Now, trapezium are also of two types. Okay, the first one is the normal trapezium, and the second one is called the isosceles trapezium. Now, we have to understand what is the difference between these two. Now, when we are talking about the normal trapezium is basically we are going by the basic property of trapezium that we have. That looks something like this. So it's basically such a quadrilateral which have one pair of opposite sides parallel. Okay, so out of the two pair of sides that we have, one pair of opposite sides will be parallel. So it looks something like this. Okay, so this is a normal trapezium, and only one line that we need to know, that one pair of opposite sides are parallel. That is the only thing we need to know. Now, coming to the next type is the isosceles one. Now, what is the isosceles? The isosceles looks like this. So, all of you first see the figure, then it will be clear to all of you that how this particular trapezium is different from the normal one. Now, the special property about isosceles trapezium is, first of all, it's a trapezium. So, already we have that one pair of opposite sides are parallel. But here, the non-parallel sides that we have, they are equal. So what is the extra feature of isosceles trapezium? That the non-parallel sides are equal. This is a very important property. Okay, so the non-parallel sides are equal. Okay, so this is basically the basic difference between the two subtypes of trapezium. Okay, I guess this is pretty clear to all of you. Now moving on to the next main type, that's a parallelogram. Okay, so let us first understand that what a parallelogram is. Okay, now parallelogram are basically of three subtypes. The first one is the rectangle, the second one being the square, and the third one is the rhombus. Okay, so first we'll discuss about the basic properties of parallelogram, and then we'll basically focus on each of the types. Okay, so let us first focus on the properties of the parallelograms one by one. So starting with the first one. So parallelogram in general, if we think, then it looks like this. So the basic property, or the basic, you can say the feature of a parallelogram is that both the opposite sides, as you can understand by the name only, that both the opposite sides are parallel. It looks something like this. Okay, so that means what is the first property? It is opposite sides are parallel. That is the basic property of parallelogram. Okay, coming to the second point. The second point is not only that they're parallel, they're equal as well at the same time. Okay, so the opposite sides are equal as well. Okay, now these were regarding the sides. Now let us talk about the angles. So first of all, these opposite angles, this pair of opposite angles that you all can see are equal, and that is applicable for both the pairs of opposite angles, right? So that means opposite angles are equal. Okay, it's a very, very important feature. Okay, and since it's a parallelogram, so it's quite simple to understand that any pair of adjacent angles that we take, since they are on the same side of the transversal and between the parallel lines, so they are basically co-interior angles, so they will be supplementary to each other. So their sum will be 1. So these are basically the basic features of a parallelogram. Now, just now, since we all have seen that there are 3 types of parallelograms we have, that is rectangle, square, and rhombus. So that means the features of parallelogram that we have already seen, those features these types already have. But other than the features of parallelogram, they also have some special features. Okay. Okay, so now we are going to discuss individually about those special features. Okay, so if we start with the first subtype, let us first start with the rectangle. Okay, now when we are talking about a rectangle, since we are doing it from quite a few years, you all are learning, you are aware of this particular type of figure, that is a rectangle. And what is the basic feature? So there's something, a figure something like this comes to our mind whenever we call the name rectangle. So basically, what is the basic feature? The basic feature is that all the angles are 90. All angles are right angles. This is the first thing that we need to know. Okay. Now next is, so I am not mentioning the properties of parallelogram once again. So properties of parallelograms are already applicable on rectangle. Now we are just discussing the special features of the rectangle other than being a rectangle. Now we all know that these are basically the diagonals of the rectangle. Okay. So if we talk about the diagonals, then the diagonals are equal. Okay, so the diagonals will be equal for a rectangle. This is a very, very important property. And not only that, they bisect each other as well. So diagonals bisect each other. So what do you mean by bisect each other? So bisect each other basically means, if I suppose name this rectangle as ABCD, then this, let me consider the diagonal AC. So then this diagonal AC is dividing the other diagonal BD into 2 equal parts. That means OB and OD are equal in the same way, vice versa. BD diagonal is also dividing, bisecting the other one, that's AC into 2 equal parts. So that means we can say AO and OC are equal. So these are few special features regarding rectangle. Okay, I think now rectangle is clear now. So let's move on to the next type, that is our square. Now this is a very, very important figure, too practical in real life as well. We come across this a lot. Okay, so let us see how it looks like. So as we all know that this is how a square looks like. So what are the features? The first feature that is coming to our mind is that all the sides are equal to each other. So this is the first thing, that all sides are equal. Okay. Other than that, if we talk about the angles, then in this case also all angles are 90. So they all are right angles. Okay. Coming to the diagonals now. So if I draw the diagonals for this square, then these diagonals are basically equal. Okay, here also the diagonals are equal. So very, very important property we can say. Okay, so diagonals are equal. Not only that, the diagonals, they bisect each other. Not only that, they bisect each other at 90. So very, very, very important property. The diagonals bisect each other at 90 degrees. So we already discussed what bisecting each other means, but at 90 degree basically means that the angle at this point of intersection, all these 4 angles are going to be 90. That is a very special feature about a square. Okay. Now, one more property which is also very, very special and that we need to know about a square is the diagonals that we all can see here. Okay, now obviously we know that a square have 4 vertices. Let me name it as X, Y, Z, and W. Now, for example, let me consider any one of the diagonals. For example, say XZ. Okay. Now, we can see that this XZ diagonal is obviously touching 2 of the vertices, one X and one Z. Now, this diagonal Now, obviously, at the four vertex, we have four angles, 90 each, that we have already discussed before. So this diagonal bisects the angle at the vertex, which basically means that if I talk about xz, then at this vertex x, this diagonal is dividing this angle into two equal parts, that is 45, 45. So very, very important feature. So that means the diagonals bisect the angles at the vertices. Very, very important point. Okay. So I guess we all are clear regarding square. Okay. Now let's move on to the next one, that is the rhombus. Okay. So let us discuss about rhombus. Now, whenever we are talking about rhombus, so let me give you all two figures. So basically, I'll just change the orientation of the figure and two scenarios I'm giving all of you, so that it becomes quite clear that what rhombus is all about. Okay. So you can also visualize a rhombus in this way, like the square that we have seen. If we tilt that square a little bit on any one of the side, then the figure that will come to our mind is basically a rhombus. Okay. So basically a tilted square. Okay. Either you can visualize in this way, or it looks something like, we can say, a burfi. Okay. Burfi you all are aware of. So it looks something like, you can also imagine in that way. So in any of one of the two ways, you all can imagine a rhombus as. Now let us see that what are the properties. Okay. So the first property, same as square, that all the four sides are equal. So all sides are equal. And one thing I don't need to say separately or mention separately, it's pretty clear from the figure, the angles are obviously not equal, right? So now coming to the next property is regarding the diagonals. Okay. So in this case, in rhombus also, the diagonals, they bisect each other at 90. So it's going to be a very, very important property. So diagonals bisect each other at 90. Okay. So this is also important. And the next one that we are going to discuss about rhombus, the property is the same that we have discussed last time in square, that the diagonals bisect the angles at the vertices. But the situation here is a little bit different from the square situation. If you all observe clearly and think about it, yeah, both in case of square and in rhombus, the diagonals bisect the angles at the vertices. But what is the difference in these two cases? The difference is, in square, since the angle used to be 90, so the diagonals used to divide the vertex angle as 45, 45. But here we can't say that. Okay, because obviously the angles are not 90. So whatever is the value of the angles at the vertices, so the diagonal will divide equally in that way. But yes, it's not 45, 45. So that is the difference between this property in square and rhombus. Okay, so I guess the parallelogram, all the three types are pretty clear to all of you. Now we'll move on to the last major type, that is the kite. Okay, now let's discuss regarding kites. Okay, now kites look something like this. So after seeing the figure, you all will get an idea that how kite is going to be like. So kite looks something like this, where if I visualize the figure as upper part and lower part, then you all will see that the upper part is a bit smaller and the lower part is a little bit, like lengthwise a little bit bigger, lengthwise, if you say. Okay. So now the properties of kites are very clear and straightforward. First is that these two sides which are adjacent here are equal, which are on the, like the upper part, and in the lower part also these two sides are equal. So you all can say that two pairs of adjacent sides are equal. Very, very important. Two pairs of adjacent sides are equal here. Okay. And the second thing that we can say is that as we can see the diagonals here, the diagonals intersect each other at 90, not bisect. Okay, so diagonals intersect each other at 90. Now, why we are saying intersect? Because if you see the figure, you'll understand. Now, this diagonal, the longer one, is bisecting the smaller one into two equal parts. But obviously, the smaller one is not bisecting the bigger one, right? As you can see that the upper part is smaller and the lower part is bigger or longer. So that is why we are saying diagonals intersect each other, not bisect, right? Okay, because only one of them is bisecting the other, not both of them. Okay, so that is one property. And here, one pair of opposite angles, which is this one. So one pair of opposite angles are equal. Okay, only one pair. So these are basically the basic properties of kite. And on an overall, if we again get back to the basic structure of quadrilateral, so if we just make a gist about the entire concept and the different types of quadrilaterals. So basically there are three basic types: trapezium, parallelogram, and kite, where trapezium have further two types, normal and isosceles. Parallelogram have three subtypes: rectangle, square, and rhombus. And at last, kite have no subparts as such, but kite individually is a type which we have already discussed. Okay, so I hope you all have understood the basic concept of all the different type of quadrilaterals, and now it's pretty clear. So I hope you all have enjoyed the topic. So those who are new to this channel, do subscribe to the channel and keep getting the new videos. Also touch the bell icon to keep on getting the notifications regarding the